I'll post a thing about the chemistry, how we're taking an ester linkage and breaking it. We're doing trans-esterification. I'll put a post on Angel under the lessons plan tonight sometime. But we're doing it with what the actual chemistry of the process is. Normally when we're going to do biodiesel, you take a vegetable oil, whether it's clean or used. Typically you titrate the level of fatty acid. I'm not going to have you do that this time. I just want you to get used to the process that we're doing. Virgin or clean vegetable oil is not as tricky as used vegetable oil. Most vegetable oils have the same amount of fatty acids before they're used. So the process has been worked up where you add 3.5 grams of straight sodium hydroxide. And 3.5 grams of concentrated sodium hydroxide, but the solution we have is only 50%, so how much are we going to have to add? Double that. So it's going to be 7.0 grams of sodium hydroxide. We're going to have a beaker. We're going to have it on a mixer hot plate. And we're going to start mixing the sodium hydroxide slowly. Then we're going to add in 300 milliliters. What it is? 200. 200?
What's that?
That's right, the bottle's got 300 milliliters in it. We're going to add 200 milliliters of methanol. Methanol. So what does that look like? Into the caustic. This material is highly, highly, highly caustic. All right, so we'll all be wearing gloves and glasses at this point. All right, because that will burn the snot out of you, basically. All right. So we're going to add in the methanol. We're going to let that mix for a little bit and start heating up the material. We're going to heat up to roughly 25 to 30 degrees Celsius. All right. Then we're going to slowly add in a liter, 100,000 milliliters of the vegetable oil. We're going to cook it for 20 to 30 minutes and watch what happens. Okay. While we're doing that, while it's cooking, I'm going to show you how to get the agave, which you don't have a process for because we're pulling this out of orifices where the sun don't shine. We're going to, I've got some yeast that they use to ferment alcohol to make, there's my thermometer, to make beer and wine. I went to there is a brew store, if y'all don't know about it. There's a brew store off of Britt David. Homebrew. Yeah. Talked to that guy, nice guy. Knows his beer. But anyway, we tried this last semester where we actually had an agave plant. And we tried to use the leaves and mush them up with some caustic and then try to convert that sugar to alcohol. As you guys know, it went anaerobic. So this time last night I went to the grocery store and just bought some of the agave nectar, which is what they actually use to make the tequila. So we're going to get that started fermenting. And I'll show you how to do that. We've got the yeast back there that the guy, the homebrew gave me, or allowed me to purchase from him. Okay, so those are the two things we're going to be doing today. The separation, we'll mix the biodiesel, like I said, 20 to 30 minutes. Most other data I've seen, the longer you mix it, the better separation you're going to have. So what I'll probably do is just let it mix at that low temperature until I come in for my lab this afternoon, turn it off, and we'll let it split. So next week, when we come back to lab, we'll separate it and see what we get. Because what will happen is the methanoic caustic will cause this to split. And in the top, you should get biodiesel. And in the bottom, you're going to have glycerin. Now, it may not be a clean split like that. There are things we can do to promote the split, and if I need to, I can add salt, sodium chloride. If things don't split, or if you have an emulsion in the interface, you can add sodium chloride to it, and that'll promote a split. I used to do that in the lab all the time. Now, the company I worked for, the chemical company I worked for, back before biodiesel was a buzzword, we had a customer, because we did toll manufacturing, which meant a customer would contact us with something that they wanted to make, and we'd figure out how to make it and tell them if we could. We actually did this process. They'd bring in rendered, we called it peacock oil, but it was actually rendered chicken fat. Tank wagons full of rendered chicken fat. And we'd do this exact same thing. We'd titrate the free fatty acid in it. We'd add enough of the methanol and the caustic to cause it to split. They'd take the biodiesel and turn it into what they needed it for. Glycerin is a byproduct that's used. Anybody know what glycerin is used in a lot? Yeah, that would be nitroglycerin. Yeah. Soap, cosmetics. Glycerin is a nice fatty oil for people with dry skin. Anyway, if we get really froggy and we want to jump, we can make soap, and we can make the glycerin into soap if we really wanted to. But we're going to focus on the biodiesel right now. So next week we'll split it off or filter it off, and we can run tests on it like pH and how well it burns. And then once we get the alcohol, we can see if we can enhance the burning of the biodiesel. And then one day you'll bring your motor oil in, right? Okay. So let's get cooking. Please, safety glasses.